Sir, I've initiated recording.
Yes.
1 minute, sir.
Recording has started. Yeah.
Yes, sir. It has to start. I've initiated it, sir.
So, Mohan, sir, I think we can start.
Yeah, the still recording is yet to get
It
changed.
has started, sir.
No, it is still the red button has not come now.
Red button is sort of still circling.
Yeah, circling, that's all. Waiting for them.
It's come up now.
Yeah, now it's okay.
Yes.
So we'll start. Yeah, we'll start now. Good day to. Hello, CSC, can you switch off the mic? Okay. Good day to one and all. On behalf of the organizing units, ACM Chennai, IEEE Computer Society Madras, and CSI Chennai, I extend a warm welcome to our speaker, Professor Sardar Islam, joining us in the meeting from Australia. And also my hearty welcome to all the participants joining from across the world and to my colleagues from the organizing units. Traditional industrial engineering and management systems can have problems of multi-agent systems such as conflicts of interest, information asymmetry, agency problems, and prisoners' dilemmas. These problems make the systems inefficient and expensive. Game theory has a great role to play in the strategies and operations of industrial engineering and management systems. Typical example is a game theory-based supply chain system. In another direction, artificial intelligence-based industrial engineering and management systems are the emerging models of industrial management systems nowadays. When the COVID-19 pandemic started, industrial engineering and management systems started being used extensively worldwide. Some of them are based on blockchain platforms and other intelligent technology platforms where AI algorithms drive the system. In today's talk, Professor Sardar will highlight how to create an industrial engineering management system using an artificial intelligence and machine learning algorithm, and also using the game theory to determine the strategies and operations for the industrial engineering and management systems. The proposed approach can provide optimal outcomes leading to efficient industrial performance. With this brief introduction to the topic, let me move on to formally introduce our speaker of the day. Professor Sardar Islam is currently a professor at the Institute of Sustainable Industries and Liveable Cities and a leader of decision sciences and modeling program at Victoria University, Australia. Professor Sardar is also a distinguished visiting professor of artificial intelligence at Universitas Sriwijaya, Indonesia, and a distinguished visiting professor at American University of Ras Al Khaimah, UAE, during the year 2019 and 2021. Professor Sardar adopts a global and humanistic approach in his research and academic works. He has undertaken rigorous scientific studies of emerging issues of computer science and other different disciplines. Professor Sardar's academic work has gained international acclaim, resulting in many honors, awards, visiting or adjunct professor appointments in different countries, appointment in editorial roles of journals and keynote speeches at international conferences in several countries. Professor Sardar has published 31 scholarly authored academic books in different disciplines, including computer science. Each of these books makes significant scientific contributions to the literature. These books have been published by prestigious publishers, and the majority of the books were published in highly regarded book series. Professor Sardar further has published about 250 articles and papers in top leading international journals in his specialized research areas, including including computer science. We are extremely happy to present Professor Sardar to the audience and request him to take over and enlighten us on game theory and AI in industrial engineering systems. Over to Professor Sardar.
Thank you. Thank you for the kind introduction. I now share the So can you see my screen now?
It is still on the edit mode. Can it be made as a...
Okay, is it still... how is... can you see it now?
Yeah, we can see it, but it is in the edit mode.
So what does it mean, edit mode? What is the problem?
You have
Sir?
to... Yes, you have to go for the slideshow mode, no?
Yes, it's now on the slide mode.
So next to home, you have animation, like the menus, you have slideshow, no, sir? Click on that and press current window, sir. Or press F5.
Yeah, F5 is, that will work, Professor. I think it's going to join again. Yes, sir. Sorry, we lost you for some time. Professor, could you bring up your screen? When we lost the connection, I think the screen also vanished.
Yeah, he's not there.
He is there. He is muted.
Okay, okay, now it's...
He just came back. Yeah. Professor, you can hit the F5. F5 will work.
But if I did, then it's going back to the, the rejoin again.
Yes, yes.
So,
yes, yeah.
So how is the slide now?
Yeah, we also see the notes. I think that we can probably switch off.
I think probably I continue if you can see it.
Actually, we can see both your notes and also the, I mean, not notes. I think the next slide is coming up on the right side.
Yes.
Yeah, this is a presenter's view.
Yes, I think it will probably continue. So the I will the talk will be structured like this. Like first, I will define what is industrial management, industrial management system, and then is industrial engineering in different areas in industrial engineering, and the concept of Industry 4. And then I will also discuss the emergence of artificial intelligence and the emerging efficient industrial management systems based on artificial intelligence. And then I will introduce the concept that industrial systems are multi-agent systems. So that will lead us to the issue of game theory. And then I will introduce the concept of artificial intelligence and the concept of artificial intelligence, technologies, models, algorithm, programming, and applications. And then how and why we do integrate game theory and artificial intelligence, especially for industrial system management. And what are those characteristics of these integrated systems and models, benefits, and applications? And there are two interactions or interrelationships between game theory and artificial intelligence. I'll explain how they are interrelated, and that will lead us to Industry 4. And then I will give some examples how the integrated systems based on artificial intelligence and game theory can be applied in different areas of industrial engineering or industrial management for developing better or improve or efficient industrial management systems. And I will give application particularly from two areas, three areas, organizational design, supply chain management, and cyber securities for industries. And then I will also discuss, though we are using artificial intelligence in industries and industrial management systems, but there are many benefits. That's why you use, but there are some risk also, and I will just explain those the benefits and risk, and then we'll just try to motivate that there is a need for improved management of the development, deployment, and application of artificial intelligence in industries, and then how we can develop better artificial intelligence based in industrial management systems so that we can have better industries and we can avoid the risk. And I will advocate that this approach can be also based on a game theory. And then I will discuss and seek your feedback on the presentation and some of the references that will be discussed. So industrial management systems, I think all the participants are probably familiar with that. It's a background discipline of industrial management systems is the industrial engineering, and it deals with designing, developing, operationalizing, and optimizing industrial and manufacturing processes, systems, organizations involving human beings, materials, technology, resources, information, and knowledge, and machineries. So what is the task of industrial manager, or what is the job of industrial management and the industrial management systems? It involves engineering, manufacturing, production, and business activities related to the processing of raw materials, manufacturing, distribution, goods and services in factories and markets. So essentially, in this context, industrial management systems involve relationship between machines, economic activity concerned with materials, humans, information technologies, procedures, and involvements in development, design, operations of organizational manufacturing and technological systems. So finally, the purpose of industrial management systems is to develop better organizational manufacturing and technological systems. So essentially what we are trying to discuss in our presentation today, how AI and game theory can be used to develop efficient, effective, and improved organizational manufacturing and technological systems. And these industrial management systems have different areas of operations and activities. So I'm sure most of the audience participants are familiar with that. But as you know, these are some of the important areas: manufacturing and information technology, supply chain management, operation and production management, quality management, organizational design, corporate governance, and activities in the area of finance, marketing, strategies and management, project management, integrated transport system, and so on. So when we are discussing in our presentation, the purpose of this presentation is to see how artificial intelligence and game theory can be combined to develop a better industrial management systems in general and in different areas listed here. But given of the time, I will not be able to discuss the applications in all different areas, but I will discuss 3 examples. One is the organizational design, second supply chain management, and third is in the area of IT, in an example from cybersecurity area for industrial managers. So this is the background, and then now we go to the main area of our presentation, which is the emergence of artificial intelligence. And we know that artificial intelligence has emerged and is changing all industrial and manufacturing systems, activities, operation, processes, technologies, substantial and very fast. So that is the area of our presentation. So essentially, this is the area of digitalization and application of artificial intelligence in industrial management systems. So what does it mean? It means that using computer programs, IT, information technologies, artificial intelligence technologies, the internet, more extensively in manufacturing, for designing and production operations, and uses integration, coordination, and management of manufacturing systems and processes. Generally, most of the cases, in simple terms, it involves including a program computer chips in different processes or systems or technologies in the industrial activities. And why we do that? It helps the things to be operation and processes to be automated, to be fast, to be safe, coordinated, environmentally sustainable, comfortable, convenient, and so on. For all these benefits, the increasingly many computer programs and IT technologies, especially artificial intelligence technologies, are being extensively in manufacturing and all industrial activities, and also in the area of industrial management systems, also managing the industries in those areas as well. So this has leads to what we do, industrial system planning. We just use traditionally we have industrial systems planning, and in that area traditionally optimization or methods have been used extensively, and also game theory models have been used, and so this is an important and very important area for academic research and real life applications. So this is the traditional system, but in that system we are now also including more artificial intelligence and other technologies. And therefore, now currently we are combining the game theory and artificial intelligence for industrial planning system, industrial systems planning, and in a more general sense for industrial management systems. And this, we know that the industrial managers are responsible for designing, developing, and applying effective and efficient organizational, manufacturing, and technological systems. And the purpose of our presentation is today how this task can be performed by using game theory and artificial intelligence. The using of artificial intelligence and game theory for the development, design, and operations of organizational, manufacturing, and technological systems. And that has led us to what all of us, we are familiar with, what is called Industry 4.0. This is one of the areas where these developments have led, but the presentation today is not only related to Industry 4.0, but it's more beyond that. But this is just the background that the presentation today in that dimension, which is just can be generally conceptualized as Industry 4.0. And in this area, where manufacturing and industries are using artificial intelligence, smart digital technologies, automation, machine learning, real-time big data. So we have seen that the two areas are coming together. One is the game theory, another is artificial intelligence in Industry 4.0, or the recent developments in industrial management systems. So they will discuss these two topics separately to give some introduction. What is game theory and what is artificial intelligence, and how they can be integrated, and then how they can be integrated to apply in manufacturing or in industry, and what are their benefits, and how to do that technically, and what are their benefits, and what are their applications. So discussing these two paradigms, game theory and artificial intelligence, I just first discuss game theory. So for general understanding of the presentation today, some of the basic things that we need to have some understanding are the following: some basic theory, some basic concepts, and then the concept of multi-agent systems and how that leads to game theory models, and game theory models, algorithm, and computer programs, and then the concept of mechanism design or game design, designing games for better systems, and then how can we develop a game theory based mechanism design model, or develop a game that can perform better than the existing systems. And then I will also briefly, it's also important to understand, what are the algorithms for these game theory models, and then how do we compute, and what sort of programming we do, and then what are their implications for improving industrial systems. So the basic areas of the game theory, there are different forms of games. There are different elements of game and different dimensions of game theory. Some will discuss some well-known games and basic solution methods, and how the game theory can be applied in many areas. But for our presentation today, just how this can be applied for manufacturing industries and also industrial management systems. So before we are discussing those basics, first we will discuss the concept or the paradigm of multi-agent systems. And many of us, we are familiar with this concept called multi-agent systems. Multi-agent systems means a system where different agents exist and they operate, they interact, and they collectively make decisions. So in many life, many systems are multi-agent systems. Like our presentation today is also a multi-agent systems. Like we have three type of agents here: the audience, the organizers, and the presenter. So this is a multi-agent system. So a webinar is also multi-agent system. And we know in all manufacturing and industrial processes and systems are also multi-agent, because different agents are involved in the operation, implementation, or decision making of all those industrial systems, and also industrial management system. So and this is actually is a very important area, especially in computer science. Multi-agent system area is very well developed, and this is also is a very important paradigm, because this multi-agent systems area is so popular and so important and useful, and it's a related area. Game theory is also very useful. Because of this, almost every year academics or sometimes practitioners, they also get Nobel Prize for their work in this area, in the area of multi-agent systems and game theory. So this is an important area. So the application of the multi-agent systems and the game theory to industrial management system is extremely important to understand and develop industrial management system based on game theory. So why game theory based industrial management system can be better than, say, the default systems? The reason is that in real life, multi-agent systems have many problems. These problems are quite well known. That like there will be imperfect information. That means different agents will not have full information about the system, the strategy, their policy, and decision making, and all that sort of things. So there will be, the information is not perfect for all the agents involved. And then there can be problem of information asymmetry. Information asymmetry means that one agent may have one type of information, other agent may have another type of information. So information may not be symmetrical, different. And they may not have incentive for cooperative and collaborating, coordinating, and making decisions for the benefit of all parties or agents in the system. So there is a lack of incentives because there can be self-interest may dominate rather than the group interest or the system interest. And there is also the issue of agency problems. We know that agency problem means in many systems there are the principals and there are the agents. So that means there can be one type of agents who are the maybe the leaders, and the others can be the followers. And then this and then and typically there can be a system where there are some owners and there can be some managers who are the agents. So in these sort of systems where there are different agents, there can be agency problems. That means the agents or the managers may not have interest to do activities for the benefit of the owners, or the followers may not have the interest to follow or do activities for the interest of the leaders. So this is called agency problems. And as I said, there can be conflict of interest. Different agents will have different interest, and different agents may come from different institutions, different cultures, and so on. So this sort of the multi-agent system problems are prevalent, existing in all areas of human life, and from the family to the organizations, associations, companies, manufacturing, to economy, and then even at the global international level. So so this is the problem why many systems, including the industrial and manufacturing system and industrial and manufacturing management system, are often not very efficient. They are not very effective, and they may not give a maximum benefit. They may be very costly. And so these are the general situations. There are more extreme situations which are called characterized called prisoner's dilemma, and so on. So those are more game theory area. We'll briefly discuss that later. So these are these sort of system. If we want to model this sort of multi-agent systems, and the game theory is the mathematical framework or mathematical model to represent the multi-agent system. So that is where the game theory is coming. So game theory is the mathematical side of multi-agent system. So game theory, then game theory is used, or what we call also mechanism design or game design. We design games for ensuring that the problems of the multi-agent systems are solved, and there is no conflict of interest, there is no agency problem, there is no information asymmetry problem, and then can lead to better systems, better manufacturing systems, better industrial management system to achieve cooperation, coordination, and so on. So this designing games, so that's why game theory is coming. We want to design game that can solve the problems of multi-agent system that we have discussed. So that is why we need the game theory. that to solve the problems of multi-agent system and then we can develop a better manufacturing, better industrial systems, and better industrial management systems. And then we need to develop those mechanisms or principles or games or rules that can solve the problem of multi-agent system to provide efficient, beneficial, and also in case of artificial intelligence can give us better artificial intelligence for manufacturing and industrial management systems. So now what is a game? Is a game is a scheme, strategies, diplomacy, action or plan or trick. For traditionally, the game theory has been developed for human being, but now game theory is also being developed for artificial intelligence agents like robots, drones, and machine, and so on. So that's why the game theory is now being integrated with artificial intelligence to develop robots, drones, and manufacturing and other processes and systems. So that's why we are discussing both game theory and artificial intelligence together, because they are being combined. For developing a robot and artificial intelligence agents, we need to use both game theory to develop cooperation, coordination among different robots, not human beings. In this case, different robots, and then to cooperate among these robot artificial intelligent agents, we need to use the game theory mathematical model. So game theory is the mathematics of strategic interdependent interactions among different agents in a multi-agent environment for optimal decision making and strategy formulation or developing actions or processes and so on. So there are in a game theory, there are different agents. These are some of the elements of game theory, different agents. And these agents, they have interdependent strategies, and there are some the rules that the agent need to follow. And if they follow and take actions or make decisions, they make decisions, and then there will be some payoffs, some sort of outcomes of those decisions and actions. So it can be benefits, it can be losses, or it can be profits, and so on. And normally these payoffs we represent by some values, give some numbers, and in terms of values. And these are the interactive, and the decision they try to make should be often rational for the agent. They are making the decisions. And then in game theory also has we need to find the optimal decision or optimal action or optimal processes. So we need to solve the game theory model. For solving, we need to use some algorithms, some computer programs, and then in the area of artificial intelligence or IT, if we develop game theory, then we can develop some strategies for different agents, and then we can develop some artificial intelligence platforms based on game theory. So the different agents will interact on that platform to make decisions and take actions, or coordinate different processes and so on. There can be different forms of game theory models. Can be cooperative, non-cooperative, and it can be also involving many people or only two people. It can be for under uncertainty, can be over time period, or it can be also evolutionary, or when we consider psychology and also human emotion, game theory models can be also behavioral game theory models. So depending what is the situation, we have to adopt different game theory models. So as I have said, there is a need for game theory. When we develop a model, we solve the model by either analytically or by computer program. We develop some strategies through computer programming by solving the game theory model. And this game theory by solving and game theory represents different systems in the background. So when we try to develop an optimal system, say for example an optimal supply chain system, then we develop a game theory model for supply chain management, and we solve the model by computer programs and algorithms, and then the results will give us an optimal or efficient or improved supply chain management system. So we use game theory for to developing or finding or designing better systems in real life. Some well-known games, so I will not go through all of them. And then this is an example of a mathematical model that can be used to develop develop the mechanisms for designing improved systems or designing a game that can give better systems or outcome for for manufacturing systems or industrial management systems. So this is just we cannot go into the detail of the mathematics. Just simply saying that there is we have to develop a mathematical model like this in the background, and then for a system like we can develop a mathematical model like this for supply chain management system, and then we give the numbers there, data, put the data, then develop, find an algorithm and do the computer programming, and then the results will give what is or will provide us an improved or efficient or optimal supply chain management system, or and an optimal or a better or improved industrial management system. So this background of game theory now, as I have said, game theory and artificial intelligence are being now integrated in many real life industrial processes and applications in the transport, in manufacturing, like using drones and robots using for manufacturing, and even in different areas of manufacturing processes are being coordinated and cooperated through the application of game theory based on artificial intelligence. So what is artificial intelligence? So these are the things we have to understand if we are going to adopt this the perspective presented at the conference at this presentation. So these are some of the basic aspects of artificial intelligence that is necessary that are necessary to understand to apply this approach. So what is artificial intelligence, and then what are the risks of artificial intelligence and benefits, and then how do we develop game theory models of artificial intelligence agents, which we call game theory artificial intelligence models, and then how do we apply them in manufacturing, in production, distribution, supply chain, or other industrial processes, and also in general industrial management systems. And then how do we develop algorithms for those models, game theory and artificial intelligence models, and what sort of computer programming is necessary, and how do we deploy and develop some portal or platform and other online web developments. And then finally, because as artificial intelligence has benefits but also has many risks, how do we develop prudent game theory based artificial intelligence models for adopting in industrial management systems and also in manufacturing, production, distribution, and other supply chain and other operations management activities. So these are the areas of knowledge and skills necessary to adopt this approach in industrial engineering or industrial management systems. So what is artificial intelligence? I'm sure all participants are familiar with this basic concept, but still I just briefly mentioned to make our discussion a bit more integrated. So artificial intelligence is a computer program, algorithm, and computer software, and combined with also a hardware that helps machine to work like human beings, to perform tasks, think, understand, feel, and sense. And for artificial intelligence can have has two aspects: on the theoretical side, conceptual side, mathematical side, but it also has implementation side, applying it to real life almost in all areas of human activities. And for implementing artificial intelligence in real life, the dominating paradigm is machine learning, which is in the area of data science, data analytics, and we develop portals and software and platforms and websites for applying in different areas, for example, robots, and in many other areas in manufacturing and industrial management systems. So in developing artificial intelligence, we use mathematics, especially operation research, statistics, computer programs, and different engineering, and then that leads us to artificial intelligence. And then this makes the machines and computers automatic, efficient for doing things and making decisions. And the game theory and artificial intelligence are actually, they are interrelated in two ways. Traditionally, game theory models have been developed for human being, for countries, for companies, or for natural agents or natural parties. But now artificial intelligence are being developed for artificial intelligence agents or multi-agent systems, like, as I said, like drones, how they cooperate, or how they coordinate, robots and transports and other industrial and manufacturing processes, how they are integrated, coordinated, and these are, the game theory should be used for, for coordinating or cooperating, developing cooperation or information sharing among different artificial intelligent agents in manufacturing and industrial management systems also. So, but on the other hand, as I said, in a brief form, traditionally game theory models are developed for natural agents, human beings or countries or companies, or natural systems. Now it is being used for other IT agents or intelligent agents or other computer systems and so on. And artificial intelligence is also used to develop and compute game theory models. For example, artificial neural networks, search algorithm, and colony and optimization, all those algorithms are artificial intelligence algorithm, and these are used also to compute game theory models. So what happens when we develop an artificial intelligence or artificial intelligent technology based on game theory, then what is the outcome? The outcome is that this new artificial intelligent agents based on game theory, they help us to develop different business or manufacturing intelligent agents or systems that is more better for formulating strategies to develop, cooperate, and coordinate and plan actions by different intelligent agents in different areas, and develop better multi-artificial intelligence systems. As I said, in the past, if we have a game theory model applied to natural agents or human beings, we develop better systems for cooperating, formulating strategies, and coordinating among human beings. But now the same thing happens for artificial intelligence and artificial intelligent agents. So we develop a better framework or algorithm or system where this game theory based artificial intelligent agents can do better cooperation, better coordination, and can formulate better strategies, can plan actions better way than if these artificial intelligent agents are not based on game theory. The game theory based artificial intelligence are being used extensively in all areas of human being, but it is also especially being used in industrial management system, in industries, in manufacturing, in industrial processes, in industrial activities, for integration of different activities in manufacturing, for coordination, for management, and essentially many of the cases it's just using computerized chips that is being used for performing those activities. And this why we do, we have stated that before, but just to repeat, this sort of game theory based artificial intelligent agents development is useful to make the manufacturing or the industrial management system to be automated, the agents to cooperate, coordinate, and the processes can be fast, can be safe, and it can be environmentally sustainable, and sometimes many of the processes or activities can be comfortable and convenient and so on. So, there are different areas, all the areas that we have discussed of the industrial management areas, including supply chain, operations management, production, distribution, all marketing, and other organizational design. So these game theory based artificial intelligent agents or intelligence are being applied extensively, and this application will be evolving in the future. So I just give an example. For example, we need to an application of one of the areas of work of an industrial manager is to make sure that the information technologies are managed properly and the information technology systems are efficient, safe, and secure. So the one part of the industrial management system is to have a cyber security system installed so that the manufacturing, production, distribution, and other operations of the company of the industry will be safe, secured, and there will be no loss. So this is an area of expertise where or the work in industrial management system where game theory can be applied based on artificial intelligence to develop better or improved information technology or information system for the industry or for the company. So this is an example. So how does it work? Like here, we have this is a cyber security game. This is why we are saying, because cyber security problem is a game theory problem, because in cyber security there are different parties, agents on generally the hacker and the cyber security manager. So this is a game involving the hackers and the cyber security managers, the regulators, and so on. So if we consider only cyber security manager and hacker, that means that there are two agents in this system, and then the task of the industrial manager or the industrial security manager is to develop a system where the cyber security or the cyber risk can be minimized or can be addressed or can be solved. And then this sort of system can be developed on a game theory modeling framework or game theory mathematics or based on game theory models as shown here. But this is a very simple illustration or example of example of a cyber security game. Here, very simple. There are two agents. There is no mathematics. It's just table represented here. But in real life, many applications will involve very advanced mathematics or in advanced game theoretic mathematical model to apply in real life. So in this game, as I said, there are two players, the industrial security manager and the hacker, and these two agents can take different actions. These actions and strategies are represented by A1, A2, A3, and the hackers strategies are represented by B1, B2, and then these are the representations. So what it means that if the hacker takes action B1, then the industrial security manager will take action A1, and the outcome will be, say, loss 10 to the manufacturing company. And similarly, if the other actions taken by the hacker or hackers, and then the industrial manager will take also different actions. So these sort of loss to the company are represented by these numbers. And then the question is, then what will be the action that the security manager, the industrial manager will take, decision will take, given this is the situation, what will happen, given this is sort of underlying situation, what the hackers can do or the security manager can do. These are the situations represented in a game theory payoff matrix. And then what is the decision the industrial manager will take? So this sort of decision making, how do we know that? So the finding that answer, we have to use game theory algorithms to solve this model. And there are many different forms of game theory models, that algorithms that we have discussed, just stated before, we didn't go to discuss. And in this case, given this different type of game theory models will have different need different algorithms, different computers programming coding. And in this case, what we can use is called mini-max algorithms. So this is called mini-max solution algorithm. That means in this situation, what is the decision will be taken when the industrial manager will think that he or she can take this decision. So the law, but the will think this is a minimum for the the security manager and maximum for the hacker. Therefore, it is called mini-max or alternatively max-min solution algorithm. And if we apply this algorithm, we can see 10 is the solution. This 10 is the solution. So what it means that if this is the situation represented here, then the industrial manager will take action A1 and the hacker will take action B2. And in this situation, it will give a minimum loss to the company and maximum gain to the hacker. And this sort of system, we can also we can bring artificial intelligence in this system. So by using the algorithm, if we develop artificial intelligence in this case, then we can do coding so that the security managers will not have to take manual decision. The system will be automated. So depending the situation, what the hacker can do, and then these artificial intelligent agents. This is the game theory based artificial intelligent agent. This agent will take action automatically, decisioning or take action or decision automatically based on the strategies that the hacker has. And in that case, the artificial intelligent algorithm based on game theory will find the solution or decision as A1 and B1. So the outcome will be 10. So this is an example where artificial intelligence based on game theory can be applied in manufacturing IT systems or industrial management systems for decision making. And another area is we can develop. This is a supply chain management model. This is a bit more. This is one of the models that I have developed with my other collaborators. So it has a real applications with large scale application, and this is not hypothetical. We can develop and a supply chain management system is based on game theory. but it's also solved as a what is called joint optimization approach. And for a real life application, we can develop a game theory model for supply chain management. And this is also based on blockchain. It can be based on blockchain and it gives an optimal contract. This is also a contract model. So, and then, this model, the definitions are given here briefly. We cannot given the time. So this is actually the involved production distribution of different goods, and especially is also artificial intelligence based, because it's supply chain management operated through artificial intelligence. So if we develop a supply chain management model based on game theory, something like this, and then and that will also be based on artificial intelligence, because the algorithm that will be adopting to solve this model can be an artificial intelligence based algorithm, and then we can do coding, for example, in Python, and so we can develop an artificial intelligence platform for this supply chain management based on blockchain, and this will be a smart contract model where different parties, the producers and the retailers in this model, they will cooperate online supply chain system. They will not give wrong information. They will not give, they will try to cheat others, and they will try to, all the agents will cooperate, collaborate, share information, and that will lead to an efficient, better, and improved supply chain management systems online. And this is based on game theory. This is an artificial intelligent model, because the computer program and algorithms are artificial intelligence algorithm, and we can deploy it online. And so different parties can use their blockchain system to access this supply chain management artificial intelligence and game theory based contract model, and if they use this model, and then the outcome, decisions and strategies, or production, distribution and retailing of this system will be efficient, optimal, and will be better improved. If the supply chain management system was not based on game theory, if the supply chain management system was not based on artificial intelligence and optimal contract. So this is just an example, and that we can also develop, another industrial management system in the area of supply chain management based on game theory, and developed as an artificial intelligence, and can to give us a better supply chain management for the industry, for the manufacturer. So for we have seen the mathematics. Then how do we implement the mathematics? And we develop, find an algorithm, develop a computer program coding, and then develop a portal and put it online. There are different algorithms which can be used to solve this sort of real life game theory based artificial intelligence systems And as I said, I'm not going to detail of those. And then there are different computer programs which are used or can be used, especially for the most important useful one is Python. And as I said, there are extensive application of this sort of game theory based artificial intelligence agents and systems in different manufacturing and industrial processes, activities and operations. And these are also facilitated by the development of this sort of systems in many other computer science areas, including internet, designing search engines, grid computing, social media, and robotics, and so on. So this sort of game theory based artificial intelligence is being developed in different areas of computer science and information technology, which is also facilitating the application of these sort of systems for manufacturing. And there are many benefits of artificial intelligence, like it improves efficiency, productivity, it gives convenience, supports activities of almost all areas of our life and living. But many of us probably don't know that there are many disastrous risks of artificial intelligence. There is the theory or concern of this survival of human beings on this earth, existential theory, whether we exist or not in the future, because the artificial intelligence based products, especially robots and so on, may eliminate human being. It may create very large scale unemployment, leading to social unrest and so on. It can create a digital divide among people, nations, companies, and parties. There can be also technological accidents, in generally, but artificial intelligence is being used extensively in almost all areas. So if there is any problem in the code, or there is a bug, or is any virus in those artificial intelligence programs, that may create severe technological accidents. For one special area of concern is autonomous weapons. We know that many of the warfares or war weapons are now activated or operated or connected to artificial intelligence. And if there is any sort of bug, any virus or accident in the artificial intelligence algorithm or program coding and or the technology, that and then these autonomous weapons may start firing erratically, and the whole world will be destroyed. So this may look like hypothetical, but the concerns are real, and many people, many scientists, physicists, and very academics, policymakers, and practitioners are concerned about those problems, privacy issues, and so on. And then what we can do, we have to certainly develop manufacturing and industries, especially to develop further Industry 4.0 using game theory and artificial intelligence and artificial intelligence technologies and other IT technology. So what can we do? We have to develop a prudent or human-centric artificial intelligence for manufacturing or industrial management systems. So this development of human-centric and the human-centric or humane artificial intelligence is a very serious task, very hard task, because different people, different companies will, or different countries will have different interests. They may not be interested to develop systems or algorithms or platforms or coding that is more humane or human-centric. So how to solve the problem? If the problem can be solved, even if we adopt the game theory approach in developing artificial intelligence for manufacturing, because we have discussed the game theory can give game theory based system can give a better systems, because game theory can be used to resolve conflict, develop cooperation, and develop mechanism that is better for all people. So if we can find some the game theory based approach for developing artificial intelligence for manufacturing, then maybe we can avoid some of the problems of the artificial intelligence that we have discussed. But this is a possibility, but in real life, the task is very hard, and it requires the cooperation and consensus at individual, national, country, company, and global level, which is a serious task. So the things are we have to do it. Things are developing. Industry 4, other manufacturing industries are adopting and will keep on adopting all the artificial intelligence and other technologies. And the conclusion is that it will be better for human being, for the world, if all these developments of technologies and also development and implementation of these technologies in real life, if this can be based on game theory, then there is a hope. Then human being will not extinct from the world one day. So I have many publications, as has been said. So I'm happy to share my publication. If people are interested, and they can send me emails or connect through me LinkedIn or other systems, then I'm happy to share my publications. And last thing, this is the presentation area is extremely important in the area of industrial management, manufacturing, for academics, for practitioners, for policymakers, and for industrial managers, for all people. And so it is essential that we give a serious attention, interest for academic work and also practical work. And I am happy to cooperate, and feedback and do mentoring in this area for consultancy or research project or any other for international cooperation. So as I said, mentoring is my official duty. So I'm happy to support activities in that area. And I will appreciate your comments, questions, or any other collaborations now, or even you can send it to me through my email given here or through other social media. Some references are given there, so my presentations are not really hypothetical. They are based on real life academic and practicing materials. So thanks to all organizers and participants. Thank you very much. Thank you. So that's the end of my presentation.
Thank you, Professor. There are some questions. I will read out those questions and kindly give your answer, sir.
Thank you.
Please explain simplified way to implement artificial intelligence in any industrial systems.
Sorry?
Please explain
Yes.
simplified way to implement artificial intelligence in any industrial systems.
Where to implement or how to implement?
Simplified way to implement artificial intelligence in any industrial systems.
For example, I give an hypothetical. In many manufacturing industries, especially in developed world, the robots are being used in different parts of manufacturing processes. For example, in cars, in car manufacturing, and in different areas of this car manufacturing, there are different areas of activities, starting from manufacturing different parts, and they are collecting different parts and then assembling and so on. And different robots are used in different stages of manufacturing car. So how do we coordinate and cooperate and share information among different robots in a car manufacturing plant, so that the whole car manufacturing process is automated and become efficient? So different robots can understand that this part should be given to another robot in another stage, which robot will receive it. So this sort of information sharing or coordination is only possible if we develop this sort of a robot system working in a manufacturing plant based on game theory and artificial intelligence.
Thank you, Professor. Next question. Can game theory be used in marketing automation?
Marketing automation can
sir.
be used everything in the world. Fortunately, certainly game theory can be used. Game theory has been used extensively in marketing all areas, and it can certainly be used for marketing automation. Marketing everything, including automation.
Thank you, Professor. The next question is, how is artificial intelligence utilized in using game theory to facilitate consensus decision making?
Because as I said, the traditionally game theory was developed for natural agents or human being. Roughly, we say human being. So if we have a game theory model, then if we solve the model, the decisions or actions we get, they are consensus based. They are agreed by all parties, and that is the main essence of game theory, because this is the decision which this is the decisions agreed by all agents. So this is a coordinated, cooperated, and consensus decision. And now this is being applied to artificial intelligent agents instead of human being. So the way the game theory was giving a coordinated sort of decision for human being, the same way, exactly 100% same way, game theory gives coordinated and consensus game or decisions for artificial intelligent agents. Similarly, exactly the same way.
Thank you, Professor. The next question, can you give some examples of game theory in civil engineering?
Like the transportation system, civil engineering transportation system. So there is a need for coordination of different trains going from one direction to another direction and connecting to bus or other transport systems. So this sort of coordination can be achieved if we use game theory to develop this sort of transportation system. this is just, and like also in a smart city, if you want to develop a smart city platform, which is also in the area of civil engineering, then coordination of different activities in the smart city algorithm, that can be also achieved and ensured by using game theory.
Okay, Professor. Next question. How secure it is to really integrate artificial intelligence to industrial management system where just one wrong action would result in a catastrophic disaster?
Sorry, can you please tell me it again?
Yes, sir.
Partly, part by part.
How secure it is to really integrate artificial intelligence to industrial management system where just one traffic disaster?
The artificial intelligence is being used currently extensively in industrial management systems, in decision making, like e-supply chain management that we have discussed. E-supply chain management is activated, operated by artificial intelligence, and instead of manual decision making, now artificial intelligence is making supply chain decisions. And so it is possible to, this will be better system, and it will avoid any sort of human mistakes or any sort of disaster.
Okay, so next question. What about career in India based on game developer?
I think the career, because there is a game theory society in India, and one interesting thing is that many of the leading game theory academics and professors in the world are from India, and so there are many people who are trying to popularize game theory in India. So I think especially if we can do good marketing for this profession, this area, I think that they have a good career prospect in India and everywhere in the world.
Okay, Professor. Next question. What is the future of gaming industry and what is basically required to join a gaming industry?
The future of gaming industry, we don't know, because the gaming industry area, we think we are living in a science fiction world. So in gaming industry is progressing very fast, and many games are possible, and this we are moving to virtual reality. So therefore, gaming industry, this career in this area, this is also very interesting and very useful. And many of these games in the gaming industry, they are and can be also based on game theory.
Okay, Professor. Next question. Is it compulsory to have coding knowledge to get hired in gaming industry?
Of course, because the gaming involves a serious coding. So we need to do coding, especially the most recent computer programs using more which are web-based, and especially the blockchain based or even general Python. This sort of computer programming knowledge is necessary to be in gaming and gaming career.
Okay, Professor. Last question. Which type of industries need the application of game theory? Is it useful in improving the production or just management policy?
Is used for production, distribution, all processes in manufacturing, and also even managing in the industries. So all areas. Not only the management of companies, the industry, but also the processes side, technologies, processes, and operations also, all areas.
Thank you very much, Professor. These are all some of the questions we have received from the participants of this program. Now I will invite Mr. T.V. Kamalakkannan, Chairman of Computer Society of India, Chennai, to formally propose the vote of thanks. Over to Mr. Kamalakkannan, sir.
Hi, good evening, Professor Sardar Islam. Good evening, all the participants. It was such a wonderful session today. Thank you, Professor Sardar, for joining in today, in spite of it being a weekend and also late evening for you. It's close to 8 o'clock for you, more than, close to 9 o'clock. So thank you very much. And today, Professor expounded on a very, very complex topic of game theory, complicated with artificial intelligence and how this can actually be designed to improve the efficiency of the industrial systems. He nicely started with what game theory is and what the elements are, and also what are the problems that are faced by game theory today. And he went on to explain what is artificial intelligence and how it can be integrated with the game theory to develop efficient systems, including controlling robots, drones, and how it can be applicable in the industry in terms of manufacturing systems, production and distribution systems. So it was absolutely a simplified version which can be understood by everybody. And then finally, you also, Professor, provided nice examples of supply chain management and also a cyber security example, so people can actually feel how they can be applied in reality, in real life. And finally, you also issued a word of caution. Everything is fine, Nanki Dori, but then there are real issues in using artificial intelligence, which may lead to possible destruction. So there is a word of caution out there by Professor. So thank you so much, Professor, for elaborating on such a complex topic in a very, very simple way. Thank you. And I would like to thank the organizers and also mainly the participants. There were close to 80 participants in the call today. So that really shows the contemporariness of the topic and also shows the relevance for our real life today. So thank you very much all the participants who joined in today in spite of the weekend. So thank you all.
Thank you, everybody. I hope to see you sometime in Melbourne.
Thank you. Thank you,
Sure,
Professor.
sir. Thank you very much.
Thank you.
Thank you.
Bye.
Bye. Yes, please. Thank you, Professor. Thank you, everyone. Bye.
Thank you.
Thank you.
Thank you. See you tomorrow.
Thank you, sir.
Yes, we have an AGM tomorrow, Sunday morning, 10 o'clock.